Hello, kids. Welcome to Algebra. Oops. Algebra Practice 1.1. All right, so the first thing you guys need to know is that algebra is all about balance. So I'm going to start out very simply and just go through very basics of what all this means so that we can build up to do some harder algebra problems. So I'm going to first do a very simple one here. 8 equals x plus 2. And so this is an example of what happens when addition shows up. And algebra comes from a root that is all about balance and reuniting x with what it needs to be. So x is what's called our variable. It is the number that we are looking to figure out, okay? So x is our variable. It's standing in for a number. And 8 is equal to x plus something. In order to isolate x, I have to get rid of this 2. How do I do that? I subtract 2. But algebra is all about balance. So if I subtract 2 from this side, I have to subtract 2 from this side. That gives me 6. That gives me 0, x plus 0. And that is the same as saying 6 is equal to x because x plus nothing is still x. So x equals 6. So this is a very simple concept here, but it's important that you don't get confused. If you're adding something and you want to isolate x, you need to subtract it, okay, to isolate x on this side so that we can find out what it is. But if you do something to this side of the equation, you have to do it to that side of the equation too. So x equals 6. The great thing about algebra is that you can plug the variable in to see if your work is correct. Is 8 equal to 6 plus 2? Yes, it is. Smiley face for us. Now, let me go ahead and erase this and talk about how it doesn't matter which way I write this equation, by the way. Sometimes we get wrapped up in thinking that things have to look a certain way. But what I'm about to do, I'm about to show you that I can do the same thing here. X plus 2 equals 8. I'm just writing it the opposite way. Same thing, doesn't matter. Subtract 2. Oh, whoops, my bad. Maybe more clear here. Subtract 2 from this side. Subtract 2 from this side. X plus 0 equals 6. We know that adding 0 to a number doesn't change it. So x equals 6. We plug it in. 6 for x. Check our work here. Plus 2. Does that equal 8? Yes, it does. So that's an example of what might happen to solve for a variable if you see an addition sign in an algebra problem like that. I'm going to show you another example that uses a subtraction sign. Okay. All right. So let's go to showing you what it looks like when you have subtraction going on. My question is, yeah, here it is. 7 equals x minus 3. So x is our variable, but we are subtracting a number here, and we want to isolate x. Well, if we are subtracting a number, the way to get back to x alone is to add that number. If I add 3 to a minus 3, that is going to get me to 0. Because literally, if I imagine a minus 3 on my number line, if I add 3 to it, it takes me back to 0. So I'm going to do that there. 10 equals x plus 0. Adding 0 to a number doesn't change it at all, so x equals 10. Okay, now remember, I can write the same problem, just switching it around, no big deal. Same thing, add 3, because if I'm at negative 3, I'm subtracting 3, but I add 3 to it, it takes me back to 0. Always do the same thing whenever you're doing algebra. It's all about balance. X minus 0. Subtracting 0 from a number is the same as leaving it alone. So x equals 10. Let's check our work. If 7 equals 10 minus 3 and 7 equals 7, we did it. So that is an example of how subtraction, if you have a subtraction algebra problem, would work. You would add to isolate x, and then x equals whatever that number is on that side. Okay. I love my eraser. This thing is so cool. You guys can always pause the videos while you're working to take some extra time. Now, some of you may be like, well, what about negative numbers? Okay, well, what happens if I have the problem negative 2 equals x plus 8? Okay. Well, I still want to do the same thing here. I want to isolate x, right? So I'm going to subtract 8 from this side. I'm going to subtract 8 from this side. These cancel out because 8 minus 8, x is isolated. Now I have negative 2 minus 8. Now let me draw this down here. Negative 2 minus 8. Now, the rules for subtracting, when you've got something like this, a negative subtracting a positive here, is you have to actually add a negative. So negative 2 minus 8 actually is the same thing as plus negative 8. So this actually gives us negative 10. How does that work? Well, here is our number line. Here is our 0 point. And we had a negative 2 here. And we had to subtract 8 from it. Well, any direction in this way is addition. We have to go this way. So if we're subtracting 8 from a negative, we are literally adding more negatives to it. So if we go 8 more in this direction, it's going to give 2, 3, 4, 5, 6, 7, 8, 9, 10. It's going to take us to negative 10. So x here equals negative 10. But don't take my word for it. Let's check our work over here. Negative 2 equals, let's do negative 10 plus 8. Okay. Negative 10, let's say I'm down here at negative 10. Adding anything is always taking us this direction on the number line. Sorry about that. This direction. And so we have to go up 8. So 1, 2, 3, 4, 5, 6, 7, 8. And that does indeed take us to negative 2. Does negative 2 equal negative 2? Yes, it does. So just remember, sometimes with algebra, negative numbers are going to show up. You just have to remember the rules of adding and subtracting, multiplying and dividing negative numbers. I like to use a number line. That just helps me visualize it better. If that helps you, great. Some people need visual aids more than others. I happen to be one of them. So that's awesome. All right, so now we've covered addition, subtraction, and the instance of what might happen if a negative number shows up. Do not panic. Don't worry, because it's just following the rules of adding and subtracting or multiplying and dividing negative numbers. And adding and subtracting tend to be a little bit more tricky, I think, than multiplying and dividing. So let's do one more with negatives here. Let's do negative, oh, I always do this. Negative 9 equals x minus 4. So instead of an addition here, we've got a subtraction. So negative 9 equals x minus 4. Well, I want to add 4 here because if I'm 4 down on my number line and I want to go back here, I have to go plus 4 to get back to 0. So those will cancel out. X minus 4, negative 9 plus 4. Okay, so negative 9 plus 4, that's going to give us negative 5, because if I'm at negative 9, sorry about that, if I'm at negative 9 and I go up 4, 1, 2, 3, 4, that takes me to negative 5. But don't take my word for it. If negative 5 is x, we have to check our work. So negative 9 equals negative 5 minus 4. Okay, so draw my number line again here. Negative 5, 0, 1, 2, 3, 4, 5. We're subtracting 4, and anytime we subtract, we're going this way on the number line. But when it comes to negative numbers, a negative 5 minus 4 is the same as adding a negative 4. So if I'm at negative 5 here, I have to add a negative 4. 1, 2, 3, 4. And that takes me to negative 9. Negative 9 equals negative 9. Love it. So that was just a little extra practice with negative numbers there. But now we're going to move on to talking about how multiplication and division look when you're doing algebra. Remember, algebra is just about balancing the equation and finding that x, whatever x is, finding it, that's what you want to do. You're trying to figure out the value of x because it's called a variable. And variables are very interesting, and you're going to do even more work. So let's do a multiplication. Let's do, fix that. Let's do 12 equals 4x. Okay, so what's going on here? 12 we know, equal sign we know, 4x. What does this mean? Well, oftentimes people see this and they don't know exactly what this means here. 4x literally is the same as saying 4 times x. But there's a symbol, another multiplication symbol that I like to use instead, and that is just a little dot here like this. This is also a multiplication symbol. I also need to make my x smaller again. That was a terrible x. So 4x is literally 4 times x. So 12 equals 4 times x. Well, how do I get x isolated if I have 4 times x? Well, you have to divide by 4 because division is the opposite of multiplication. So if I have 4 times x and I divide by 4, and that line here is a fraction line, but the fraction line literally is a division line. How do I know? 1/2 literally is a division line because if the decimal for this is 0.5. How do I know? You always take the numerator and divide it by your denominator. This is your dividend, this is your divisor. 2, does 2 go into 1? No, it does not. So you have to put a decimal, add a 0. Does 2 go into 10? Yes, it does. Got to move your decimal up. 5 times, subtract that, you get 0. 0.5, 1/2 is 0.5. So 0.5, 1/2, it literally is a division symbol. So don't get thrown off by this. This may look kind of scary, but it's not. All it is a division sign. That's what fractions do. They divide things into smaller pieces. So I'm going to take 4 divided by 4 and 12 divided by 4. Cancel that out. X equals 12 divided by 4. Does 4 go into 1? No. Does 4 go into 12? Yes, it goes 3 times with no remainder. nice, crispy, x equals 3. Don't take my word for it, though. 12 equals 4 times 3 if we have 3 equal to x. So x is 3. Plug in 3 for x. We get 12 equals 4 times 3. 12 equals 12. So that works. That absolutely works. And remember, what I'm about to do, just be mindful. I'm going to repeat this point, and it may seem silly, but it's a very important point that sometimes I think we forget in math. So what you have to do is realize that 12 equals 4x is the same as 4x equals 12. No matter what side it's written on, does not matter. This is the same thing. 4 times x equals 12 divided by 4 divided by 4. Remember, don't get scared by that fraction line. 4 divided by 4 is 1. 1x, 1 times x literally, equals 12. 1 times anything is itself. X equals 12. Oh, x equals 3. Sorry about that. Because 12 divided by 4 is 3. Whoops. Okay, there you have it. So no matter where things are written, don't panic. Just remember, you're solving for x no matter what side of the equation everything's on. You can have x on both sides of the equation. I'm going to give you guys a little bit of examples of that towards the end, because you got a follow-up coming up that follows that. So that is multiplication, but what about division? What if I have 9 equals x divided by 3? Whoa, that's kind of scary. What's going on there? Well, how do I isolate x? It's divided by 3. What do I do? Now remember, there's kind of a 1 here. Anytime you don't see anything, there's a 1 there. So 9 equals 1/3 times x. You can think about it that way, okay? You can still think about it as 9 equals x divided by 3. What I need to do is I need to multiply this by something that's going to get rid of this 3 down here. So what do I do? Well, if it's 1/3 x, 1/3 times x, what do I multiply 1/3 by to get it back to be the number 1? I would multiply it by 3 over 1. Okay, so 1/3 times 3 over 1, okay, gives us 3 over 3. So I'm just working on the 1/3 here, times x. And that gives us 1 times x, which gives us x, because 1 times anything is itself. So I took what's called the reciprocal of this fraction here, okay, and I multiplied it to make sure I canceled out, because 3 times 1 is 3, 3 times 1 is 3. Now I have x all by itself over here, but whatever I do to this side, I have to do to this side. What did I multiply this 1/3 by? I multiplied by 3 over 1. Well, let's move this down here. 9 is the same as 9 over 1 times 3 over 1 gives us 27 over 1. And 27 over 1 is always going to be equal to whatever the number on top is, because any number divided by 1 is that number. 27 equals, oh, look over here, all we have is x left. So 27 equals x. Don't take my word for it. Let's erase this, get a little bit crispier about this. How do I know that this is going to be the case here? Okay, well, 9, and actually let me erase this again. This is what we had. This is what we started with. 9 equals x divided by 3. All right, well, 9 equals, let's plug in our 27. 27 divided by 3. I could have had a 1 there. 1 times 27 is still 27. 9 equals 27 divided by 3. Let's see if that works out. 27. Does 3 go into 2? No, it does not. Does 3 go into 27? Yes, it does, evenly. 9 times 9. So 27 divided by 3 is 9. That is equal to 9. And there you have it. Mr. Smiley Face has come back. So 9 equals 9. We have full balance. Algebra equation is satisfied. Okay? Because x equals 27. 27 divided by 3 is 9 equals 9. All right, so do not get scared when you see that division symbol. It's the fraction symbol. It's the division symbol. As we get older, we are rarely, ever again, going to see what you saw when you were younger. This symbol here is practically non-existent. You're usually just going to see the line here or this, right? And this is what you're going to see most of the time. So get used to seeing the division line there, kids, with the fractions. All right, yeah, that old school division symbol. Not going to see it much moving forward. Okay, so we've got a division example there. Let's look at a multiplication, something a little more scary looking, something with fraction. It looks, we just did a fraction, but this one's a little scarier looking. So let's do 20 equals 4/5 x. Okay, 20 equals 4/5 x. Interesting. Oh man, what are we going to do here? Well, we have to isolate x, and we know that this is the same as saying 20 times. Oh, whoops. Oh, that's not what I'm looking for. 20 equals 4/5 times x. Oftentimes you might see it written like this. 20 equals 4x over 5. Same thing. Don't get scared. Do not get scared. It's okay. I like to always put it in the way that makes sense to me. 20 equals 4/5 x. 20 equals 4/5 times x. So now we have to think about what do we do to get rid of 4/5? Well, there is a general rule that in order to get rid of something, you have to multiply by its reciprocal. And that is division, right? Fraction division. Literally, it's multiplied here. So I'm literally have to divide 4/5 times x by 4/5. Oh my, that's scary. Yeah, 4/5 divided by 4/5. But what we've learned, division of fractions, is basically multiplying by what's called the reciprocal. And we did that earlier, except for now it's just more clear. 4/5, you take the first one in the sequence, leave it alone. This one, you flip it. So 4/5 divided by 4/5 is the same as multiplying by 5/4. Because that is what you do. You multiply by the reciprocal. And the reciprocal, I think I misspelled that. It's terrible if I did, but I'm doing math today. I'm not a language arts teacher right now. All right, so multiply by the reciprocal. Why? Well, let's go down here for a second. 4/5 times 5/4. Multiplication and division of fractions is great because you don't have to worry about a common denominator. 4 times 5 is 20. 5 times 4 is 20. Any number divided by itself is equal to 1. We did, in fact, isolate x over here because we multiplied by the reciprocal. We divided by 4/5, which means we multiply by the reciprocal 5/4 to isolate x. But whatever we do to one side of the equation, we have to do to the other. What did we do here? We multiplied by this reciprocal 5/4. That means we have to do 20 times 5/4. So let me erase some of this work here. You can always pause the video and go back. You can always pause the video and go back. That's the great thing about some of the benefits of online teaching. All right, so let's go ahead and let's move to make this bigger. 20 equals 4/5 x, which is 4/5 times x. We divided by 5 over 4, well, by 4 over 5, which was the same as multiplying by 5 over 4, which is the reciprocal, and this reciprocal is found by flipping the fraction. And we did that to isolate x, because now we've canceled that out. What do we do over here? Well, let's take our 20 and let's turn 20 into a fraction. 20 is the same as 20 over 1, and I have to multiply it by 5 over 4. All right, so I'm going to do this two ways to show you. 20 times 5 is in fact 100. And then 4 times 1 is 4. And 100 divided by 4 divided into 4 parts. Let's go over here to check it. Does 4 go into 1? No. Does 4 go into 10? Yes. 2 times. Bring down the 0. Does 4 go into 20? Yes. 5 times. There you have it. 100 over 4 equals 25, and x equals 25. So there is this way. Now, let me show you a little bit of a trick you can do if you want. Okay, and I'll show it to you over here. I have, separate this out. I have my 20 over 1 times 5 over 4. Now this is called canceling out. I asked some of the kids what this was the other day. It's called canceling out. If you have across the numerator and the denominator of 1 here that you can like reduce a little bit, you actually make your job easier. So what I'm going to do here is I'm going to say, are 20 and 4 divisible by the same number? Yes, they are. 4 divided by 4 is 1. 20 divided by 4 is 5. And 5 times 5 is 25. So that canceling thing, I could have done that over here. I decided not to because I just wanted to show you the way to do it. You don't have to do this. This is just a trick that will make your life easier. So, erasing that horrible line that I should not have drawn. Now moving to what I've got here. Need to make a little more space. I have x is equal to 25. Okay, well, don't take my word for it. Let's go ahead and erase everything, all of our work, all of the rules that we just followed, and let's see if x as 25 actually works here. Let's see if it works. All right, so 20 equals 4/5 times 25. 20 equals 4/5 times 25, and 25 is the same as 25 over 1, right? Okay, 20 equals 4 times 25 is equal to 100. 5 times 1 is equal to 5. 100 divided by 5, that's all this means. 2 times 0, it goes in 0 times 20. Yep, 20 equals 20. There you have it. Big smiley guy for this one. Very nice. So x does in fact equal 25. All right, so we've covered some basics. There's a lot of things that look scary when you start algebra, and that's okay, because new things, when you encounter them, do kind of, they can be kind of scary. But what I've found is that you stick with what you know and you put it in terms that you can understand, and then you build up little by little to learn how to do it. So let's do something with a decimal. What happens if you encounter a decimal in algebra? So let's do 30 equals 0.5x. Decimal, kind of scary looking there. Literally, 0.5 is the same as 1/2, but we're going to treat it as a decimal here. I prefer fractions, but it is what it is. All right, so we need to isolate x, which means we need to remember that 5x here, this is 30 equals 0.5 times x. Remember, this is our little multiplication symbol. I don't want to use x because I've got my variable x. It's confusing. So 0.5, I'm going to do a better 0.5 here. 0.5 times x divided by 0.5. Any number divided by itself is, in fact, 1. X equals 30 divided by 0.5. Well, now you have to go about your rules of decimals. So let's do 30 divided by 0.5. We do not like, when we divide with decimals, we do not like leaving the decimal point here. So what we have to do is, I think Miss Carroll calls this scooping. We have to move the decimal point here. But anything I do on this side, I have to do here. So I initially had a decimal point there, 30.0. Now it's 300 divided by 5 now. 5 goes into 30. 5 goes into 30 times. 5 goes into 36 times. And then 5 goes into 0 times. 60 times 5 is, in fact, 300. So here, 30 divided by 0.5, which I did there, is going to go ahead and give us 60. Well, don't take my word for it, though. Let's check our work. Let's check our work by plugging in our equation here. So 30 equals 0.5 times 60. Okay, so 30 equals 0.5 times 60. Well, let's go ahead and check to see if that works. 60 times 0.5. 5 times 0 is 0. 5 times 6 is 30. Rules of multiplying with decimals. I had this one place over here. I have to take this now over 1. And that, in fact, does give me 30. 30 equals 30. Happy face guy is here. So with decimals, you just have to remember your rules of multiplying and dividing with decimals. So that's why algebra comes after work with decimals and fractions, because you have to understand those rules in order to better understand and make sure you go through an algebra problem effectively. So that's why, kids, you have to know the rules of decimals and fractions once you get to algebra. All right, so let's move on to another example. Goodbye, smiley face guy. Oh, goodbye. Goodbye, friend. All right, so let's look at another example here. Let's do a variable on both sides of the equation. Now this is where you might get scared. I actually was a little scared of this, but I'm going to persevere nonetheless. I have x minus 2 equals 2x. That's the same as saying x minus 2 equals 2 times x. All right, so I want to isolate my x here. Oh boy, so what do I do? Well, I've got 2x here. I've got x minus 2 there. What do I do? Well, let's think about this. Why don't we try to get the x's all on one side of the equation first? So can we do that? Let's do that. So I'm going to subtract an x here. Subtract an x here. And that 2x minus an x is going to give us 2x minus an x is going to give us an x. Actually, I don't like the way I did that. Scratch that. And in fact, I'm going to scratch these double variable ones until I get a full handle on them because I do not want to give you guys bad advice. All right, so let's not worry about the x on both sides yet because I need to make sure I practice that for you. But let's do a little more practice of what we've got here. So x minus 4 equals 8. Well, there we have it, and that's the same as saying 8 equals x minus 4. Doesn't matter which way it's written. What do we do? Well, let's go ahead and isolate x plus 4 to both sides. Remember our number line thing. 8 plus 4 is 12. X equals 12. Let's plug it back in. X is 12. If we plug that into this side the way we wrote it, 8 equals 12 minus 4. 12 minus 4 is 8 equals 8. There you have it. So that's just another practice one. All right. Let's try another practice one here. Oh, here is one that's going to combine a couple of things. This one, I'd like you guys to take a look here. 2x minus 4 equals 8. So we're making this a little more complicated. Okay. Well, what do we do first? Well, let's get rid of this 4 by adding 4 to both sides. These cancel out because negative 4 plus 4 gives you 0. 8 plus 4 gives you 12. But now we have the 2x that comes down. 2x equals 12. Well, what do we do here? Remember, 2x is the same as saying 2 times x, right? Because if you don't put anything in between, you assume multiplication. General rule. Now let's divide by 2. Okay, we're going to divide this by 2. The whole number divided by itself gives you 1, which isolates x. 12 divided by 2 gives us 6. However, let's not take my word for it. Let's go check our work. 2x minus 4 equals 8. Well, let's substitute 6 here for x. And forgive me, but I'm going to put 6 in parentheses to show that this is multiplication. Minus 4. We have to remember our order of operations. Always do multiplication and division before addition and subtraction. So 2 times 6 is in fact 12. Minus 4 equals 8. 12 minus 4 is 8 equals 8. Yes, x equals 6. Okay, so you can put these all together and have more complicated equations like 2x minus 4 equals 8. That just means you have to go through a couple of more, you have to go through an extra step to isolate your variable. So let me show you a couple more. And really what we're looking for is to get the basics down. Algebra is about reuniting x with whatever number it is. It's about balance. It really is a lot of fun. And the great thing is it's self-regulating. It's like, you know if it's right, all you got to do is plug that number back in. So let's do, let's do one that looks hard. X divided by 2 minus 4 equals 8. Okay, so we've got x over here. We want to solve for x, and remember x is our variable. It's standing in for a number. We want to find out what that number is. Reunite x with a number. Let's start by adding 4 to both sides. 0, 8 plus 4 equals 12. A negative 4 plus a 4, remember, I always like to think about it on a number line. 1, 2, 3, 4. This is negative 4. This is positive 4. Whoops, my bad. 1, 2, 3, 4. So this is the positive side of the number line. This is the negative. You have a negative 4 and you go up 4. 1, 2, 3, 4. You're back to 0. So that is 0. And now we have x divided by 2 minus 0, but anything minus 0 is the same thing, equals 12, right? Okay, x divided by 2 equals 12. All right, so what do we do? Well, we're dividing by 2, but remember, there's a 1 in front of here. Let's imagine a 1. And anytime you divide, you multiply by its reciprocal. So 1x divided by 2, if we multiply, or if we divide by 1/2, that's the same thing as multiplying by 2 over 1. So that means that we have 1/2 times 2 over 1 next to x here. 2 times 2 is 2. 2 times 1 is 2. 2 times 1 is 2. This gives us 1x. X. All right, so x equals x times 2. So x divided by 2 is the same as multiplying by 2 over 1. So I multiplied this by 2 over 1, but what I did here, I have to do over here. So now x is going to be equal to whatever 12 times 2 over 1 is, but 12 is the same as 12 over 1, because any number divided by 1 is that number. So 12 times 2 is 24, 1 times 1 is 1, and we get x being equal to 24. All right, but don't take my word for it. Let's go ahead and erase all of my work. Remember, you guys can always come back to the video. I got x equals 24. X divided by 2 minus 4 equals 8. Okay, so let's plug in 24 for x. 24 divided by 2 minus 4 equals 8. Order of operations says always do division or multiplication before addition and subtraction. So 24 divided by 2 is 12. Bring down the minus 4 equals 8. 12 minus 4 is 8. 8 equals 8. Therefore, x as 24 is correct. And there you have it. So do not despair. Do not get frustrated. Just remember, take your time and remember that you just have to get x on one side of the equation. Isolate it, balance it out with whatever number it's going to be. Okay? All right. So let's go ahead and look at if I have any more problems here. I have a whole list of problems that I want to do. All right. Yeah, so here's another one. 2/5 x minus 4 equals 8. Okay, so this seems a little bit more difficult, but it's actually the same as the last one. Last one, it was just x divided by 2, but it's actually just 1/2. So 2/5 x minus 4. Remember, let's start by getting rid of that 4. 12 equals 2/5 times x. Well, we have to divide by 2/5, which is the same as multiplying by the reciprocal, which is 5 over 2. And so I literally can cross that out over here because that's just what it is, but multiplying by the reciprocal proves it. 2 times 5 times 5 over 2 gives me 10 over 10, which is equal to 1, which isolates x, but multiplying by the reciprocal, I got to do it over here. 12 is the same as 12 over 1 times the reciprocal. You have to balance here. If I multiplied by 5 over 2 here, got to do it over here. So x equals whatever this is. 12 times 5 equals 60. 2 times 1 is 2. 60 divided by 2. 2 goes into 6 3 times. Goes into 0 0 times. 30. X is going to be equal to 30 here. Okay. Well, like I keep saying, oh, sorry, I gotta get my smiley face guy. Yay. All right, so let's go ahead and erase this and make sure that we are double checking our work by seeing if 30 is in fact the answer. Always got to double check our work. Because algebra is self-referential. It checks itself. It's great like that. You don't have to ask a teacher or anything. All right. So 2/5 x. If x is 30, that's 2/5 times 30 minus 4 equals 8. Okay, so 2/5 times 30 is the same as 2/5. Oh, my bad. I forgot to do something here. Make my life more difficult. We have to make sure we add 4 to both sides first. 12. Let me make sure I note down that our guess here is that x is 30. All right, so 12 equals, remember 2/5 here next to the 30 with the parentheses means multiplication. So 12 equals literally 2/5 times 30 is the same as 30 over 1. Okay, and I'm going to go ahead and go this way with it. 30 times 2 is 60. 5 times 1 is 5. 60 divided by 5. Okay, it goes up once, minus the 5, 1. 5 goes into 10 twice, is in fact 12, which is equal to 12. Yay! So 30 as x is the correct answer. However, let's go and show you real quick an easier way. This was the canceling out thing that I showed you a little bit before. You could have done this. So I'm going to pull this over here. 2/5 times 30 over 1, right? And we're looking to get 12. Well, I can cross cancel here because 5 and 30 are both divisible by 5. So I divide 5 by 5, and that gives me 1. I divide 30 by 5, and that gives me 6. 2 times 6 is 12. 1 times 1 is 1. I still get the same answer because any number divided by 1 is that number. And there you have it. So this cross-canceling thing, you can do that too, or you can do it this way. I kind of like this way because it teaches you the basics. This is a little more advanced, but yes, x in fact equals 30. So 2/5 times 30 minus 4 does in fact equal 8. Okay, so we're almost done. Hopefully you've made it to the end of the video. I know this video is a little long, but I did want to be pretty comprehensive with very basic stuff that I think is really important that we learn with algebra. Let's see if I have any more problems that I have for you. Let's see here. Yeah, let's do one more. Let's do 120 equals x over 15 plus 20. So 120 equals x over 15 plus 20. So, interesting. Let's see here. Well, let's go. Well, first we've got to subtract 20, because if you're 20 on the number line this way, you're plus 20, you got to get back to 0. You got to subtract 20 to get there. 0. Now we have x over 15 equals 120. Now remember, this x over 15, don't be alarmed, it's the same as 1 over 15 times x. So 1 over 15 times x equals 120. Divide by 1 over 15, which as we know is also the same as multiplying by the reciprocal, which is 15 over 1, which gives us 15 over 15, which gives us 1. but I multiplied by 15 over 1 here, which means I had to multiply by 15 over 1 here. And 120 is the same as 120 over 1 times 15 over 1 gives us, what is 120 times 15? Says that that is 1800. Let's double check here. Actually, let's just do it right here. Why not? Okay, let me erase something here. Okay. We divided by 1/15, which was the same as multiplying by 15 over 1. 120 times 15. 5 times 0 is 0. 5 times 2 is 10. Carry the 1. 5 times 1 is 5, plus 1 is 6. Go to the next place, have to add the 0. 1 times 0 is 0. 1 times 2 is 2. 1 times 1 is 1. Add them together, we get 1800. It looks like we have 1800 equals x. Well, let's see if that's right. Is 1800 correct? This one was one I kind of made up on the fly. I'm not sure. Well, let's find out. Did I do something wrong? Who knows? Let's figure it out. That's the great part about math, is that you can figure it out. Okay. So I have 1800 as x. Let's plug it in and see if it works. I might be wrong, I might be right. Clean this up a little bit more. Clean up my board. All right, so let's plug in 120 equals 1800 divided by 15 plus 20. Well, let's see what happens. 1800 divided by 15, what is that going to give us? Oh, I think I did this wrong, guys. We're going to have to fix this one, because 1800 divided by 15 is 1, 2, 120, and 120 plus 20 is not equal to 120. So this 120 is not equal to 140. So we did something wrong. So let's start over. X is not, oh, before I do that, also guys, this goes to show that sometimes you get wrong answers, and guess what? Don't cry. It's okay. Even teachers get wrong answers. That's actually one of the advantages of having me teaching math sometimes, guys, is that you see that teachers make mistakes too, and I don't mind it. I actually like making mistakes in front of you guys. I think it's fun because you guys get to see that I'm human. And you definitely see that on a soccer field lately, dear Lord. All right, so let's start again. Subtract 20. Oh, I know what I did wrong now. I forgot to subtract 20, because now it's 100 equals x over 15. Oh, yeah, okay. Well, now we know that this is the same as 1 over 15 times x. Oh, whoops, my bad. Now I'm excited because I figured out what I did wrong. This is the fun part. Equals 100, but I'm going to divide by 1/15, which is the same as multiplying by the reciprocal. Okay, which is going to get x as itself. But if I multiply by the reciprocal here, I have to do the same thing over here. And this is the same as 100 over 1 times 15 over 1, which gives me x is equal to 1500, because this gives me 1500 over 1, which is 1500. All right, now let's see if this is the correct answer. So I'm going to write the problem again up here. I'm going to erase everything but the answer. 1500. Let's see if we got it this time. And that's why you always got to check your work, kids. Always check your work. Cannot just assume that you got the right answer because you got a number. And it's also important to show your work. On your follow-up, if you don't show your work, I'm not going to give you any credit for it, just for the record. Nor is Mr. Matt, nor Miss Carol. They are not going to give you credit. All right. So let's plug in 1500. So 120 equals 1500 divided by 15 plus 20. All right. Well, 1500 divided by 15. Let's do that work here. Zero. Oh boy. So 15 goes into 1500 100 times, plus 20 equals 120. 120 equals 120. Hallelujah. Got it. Hey, we did it. So there you have it, kids. I just gave you some algebra practice. You have a follow-up worksheet. Some of you may have more. Some of you may have less. Doesn't matter. You got plenty of follow-up work to do today. I really appreciate you tuning in, but please, please, please remember to follow the steps. You have to find what x is. You have to find x. X is your variable. You're trying to reunite it with whatever number it is. It's from the Arabic algebra, okay? And I think you're going to enjoy algebra once you really get into it. So we've covered some basics. Just remember, you're going to have to review all of that, work with dividing and multiplying and everything with decimals and fractions, because those rules apply in algebra. All right, so thank you very much, kids. This has been Algebra Practice. I hope you've enjoyed. Go do that follow-up activity.